Today I'll be showing off some of the features of DarkShield in terms of unstructured data masking. What I'm currently showing right now is a GUI that we've built on top of Eclipse called IRI Workbench. This is where we're going to be doing most of our work through. This is also the same GUI that we share with our other Shield products like Field Shield for structured data masking. So there are a lot of functionality that's shared between those two products. I have a test documents folder here. This particular one I have, which contains movie lines. But yeah, in essence, all it is just some lines from some popular movies. I don't exactly know which ones. I think Austin Powers is in there. We're also going to be demonstrating a new upcoming feature we have, which is access to S3 buckets directly. So you can communicate it from file system to S3 buckets to other S3 buckets, and so on. It contains things like a bank statement Word document. I'll just open it up and show what that contains. The same thing as a text file. So this is what is the contents of that Word document, which you'll see here. And then just to round things off, a PDF file that contains a bank statement. Also just a JSON file containing emails, just things like the actual email, the subject, some additional unstructured free-flowing text within, and the content, of course. Going forward, I'll just switch back to IRI Workbench here. What we want to be able to do is, to start off, is to classify the data that we will be searching for. And the way we do that is through a common interface we have called the Data Classes and Groups preference page, which contains a list of preloaded data classes that we already have with this installation. So things like credit cards, email addresses, names. So each one of these data classes contains a list of matchers. So for example, an email address contains a single matcher, a regular expression pattern to be exact, which will be used to match on instances of this particular data class within our sources. Some other data classes can be more complicated. What I'll do is I'll create a new one for names. I'll call it names NER because what we want to be able to do is do named entity recognition in this data class. Now for the matchers, what I'll select, I'll click on add to create a new data class matcher for this data class. Here you can see the different types of matchers. So the one that you already seen for emails is a regular expression matcher. So you can, create a regular expression pattern here. You can also attach a validation script for it. So if you have things like credit card numbers, you might want to be able to validate that the checksum adds up to a checksum of a credit card number. So it adds a little bit of extra validation to whatever regex pattern that you've able to match on. We also have things like set file matchers, which is just dictionary lookup. So if you imagine, you can have, say, a list of names within a set file, which you would want to be able to look for, or a list of addresses, as one may have it. And the one we'll be interested in today is the NER model, the named entity recognition model. This allows us to find named entities within our sources. Now, NER, what makes it special is that it can use the context of the sentence to derive where the named entities appear. So, for example, if we have an NER model trained on person names, right, what it will be able to do is detect that John is a name in the context of the following sentence. I went out for lunch with John. So this allows you to basically find person names or any named entity without actually having a preset dictionary lookup in essence. So this would be a great addition to things for in your context, we believe. So, and you can have named entity recognition models for practically anything. So person names, addresses, organizations, dates, things of that nature. So what I'll do is I'll select a pre-trained model that we have available for person names. There are other pre-trained models that you can download online for things like dates, organizations, and what I'll be showing on later in the demo is how you can retrain your own model for your specific domain. So you can take a pre-existing pre-trained model and retrain it to to be more effective within the domain that you're going to be using it in. So for example, if you have instant message and chat logs, which are going to be more unorganized, have more misspellings than, for example, news articles, which is what this particular pre-trained model is trained on. So I'll go ahead and click OK to add it. What I'll do is I'll add another matcher here, because you can have multiple matchers, and this one I'll select a set file. I just have a set file here, I'll show it to you later, but it just contains some info that we may be able to want to find, and I'll explain why in a minute. So that's a new data class created. So we can go ahead, click OK. This data class is now in our preferences, and we can reuse it across our application as we please. I'll just go ahead and apply and close. What I have here is just, 2 lines. Every line is just whatever we want to find. So one is Jane Customer here, which is just a name, and this is an account number for her. Now, one of the reasons why you might use a set file, first of all, you can use it to augment your named entity recognition, right? If you have just a list of expected names, you can just put it straight into here and use it alongside your named entity recognition model to match on more names. What you can also do, this has come up before, is for GDPR compliance, right? Let's say a person wants to be forgotten in a particular context or application. You can just enter all of the data you have on that person into the set file and perform a search using this set file, search and mask. So here we have, again, the name and just an account number. Again, this doesn't really match with our data class because this isn't a name, but this is just a good way to demonstrate set files in the context of one document that I have. And I'll also explain why, a set file is more effective in that context rather than a named entity recognition model. What we want to be able to do now is actually perform our search and remediations. So we have a wizard here called New Dark Data Discovery, which creates a job file in essence, which we can run to perform the search and the remediation. So here we can name the folder where we're gonna put this the settings file. I'll go ahead and click next. Here we can specify the source URIs for the sources of our data. So I'll go ahead and click add. The first one we're gonna add is this test documents folder in our project explorer. So I'll go ahead and click browse. I'll select test documents and select that. Here you can also include things like which file names to include within this particular folder using a regex pattern, which ones to exclude, whether or not this is going to be a recursive search, as well as you'll be able to select the different file types that you want to be able to search through. So these are the ones that we currently support, including some image file formats, which I won't be demonstrating today, but we support it through optical character recognition and facial detection recognition and image bounding box redaction if that is of any interest. I'll go ahead and just select all, so it'll be searching for all file types. Now, what makes this different than just selecting an extension to include within a regular expression pattern is that it can also use some magical bytes that can be found in some formats, like PDF documents, for example, which can be indicative that this particular file is a PDF file, even if the extension doesn't say .pdf. So it's a bit more encompassing in that regard. So I'll go ahead and click OK. And I'll add another source for our buckets. So the first type that we had for our source was the file system. Here we have 2 more SMB shares, which is just things that we can share on a local area network through this SMB Windows protocol. And then also S3 buckets. So this is the new feature that we've developed. It's currently in internal testing, but will hopefully be released in our beta channel in the near future. I'll go ahead and click this S3 bucket. Here we can specify the bucket name that we're going to be using, as well as the access key and secret key. Let me go ahead and get those. This bucket doesn't really contain any, important information, so you can copy those if you wish. Then you can also select the file types again. The prefix is for allowing you to search particular folders in an S3 bucket. So everything in an S3 bucket is a key object, key value object parent. So folders are sort of represented by having a prefix. So you having like a folder slash important stuff, right? So that's what you would put in the prefix in order to search for that through that particular folder only. Without the prefix, it just searches everything in that bucket.
I think where we're moving towards with DarkShield is a JDBC support as well, so that you would be able to, I guess in this instance, Dimitri, share the same discovery and masking choice interface without having to go through a separate set of field shield wizardry. Is that is the end goal, I assume?
Yes, and we are currently looking into developing the JDBC connector. We do also support other NoSQL databases in DarkShield like Mongo and Cassandra, and there's also overlap with that in FieldShield, where FieldShield can also access Mongo databases, Mongo collections.
Yeah, the other thing that's worth maybe discussing, if not demonstrating at some later point with respect to structured collections for things like Hive or Oracle or whatever, are the capabilities of FieldShield and the approach that's taken during the masking through a different scripting language called SortCL, which exposes a lot more than just masking. Because once you're into that syntax, you're able to do ETL operations, change data capture, replication, reporting, data wrangling, move into analytic tools like NIME. And there's a whole lot more going on around the FieldShield infrastructure, not just in terms of masking and data transformation, but also in terms of data discovery. There's maybe 4 or 5 different just search wizards associated with schema. There's more to talk about and demonstrate with respect to structured if you're interested in looking at that specifically. But if you're just looking for sheer convenience, and not having to use different wizards, for example, to get at the consolidated search of structured and unstructured sources and their masking simultaneously, then our JDBC interface to this will be what you'd want. And that's also in development. But even if you don't use that consolidated approach, you would still have access to the license and the wizards and everything here in the same workbench, which is already sharing the same data classes and masking functions. So in terms of consistency, that's already there.
Now that we've selected our data sources, you can go ahead and also select the targets for where we want to put the remediated files. I'll go ahead and put that into another S3 bucket, DarkShield demo remediated, and it's in the same under the same account. So I'll go ahead and paste the same access and secret key, select the same region, and click OK. Just to show, I'll go back here and go down to this remediate folder and show that this contains no objects. So now the next page here, we can select the metadata information that we want to collect on our search results, things like the search matcher that matched on it, the actual result. The span is where that particular search result was located within the original document. And this can vary depending on the file format. So, a regular text file might just have character offsets. A Word document can have paragraph and word, things of that nature. So I'll go ahead and just select all. Here we can now create search matchers. And the search matcher is just basically a mapping from a data class, which we either created in the preferences, or we can create ad hoc within this wizard, and a data rule. And the data rule defines how any instance of what we matched with this data class will be masked. So I'll go ahead and browse and select our names_ner data class, which we've created previously. And I'll create a new rule. I'm gonna create a format preserve and encryption rule through this UI here. Now, format preserve and encryption is a good way of consistently masking things like names, because what it'll do is it'll retain the length of the original text, the capitalization, the any non-alphanumeric characters like dashes, but it will, scramble all alphanumeric things. So, and characters will be replaced by characters, and numerals will be replaced by other numerals. So it's also good for things like credit card numbers as well, where you preserve the format of the credit card number, but just scramble the numbers in essence. So here you can define a passphrase. They'll just use the default one. The passphrase can either be just a regular string or an environment variable or something that is obtained from the file. We've also added recent integration with key management tools. We'll call this search matcher names matcher. We won't go into filters here, but what you can do for things like semi-structured sources like JSON or XML is also define certain filter language, in essence, certain filter expressions to filter which portions of the file you want to search through. So for example, JSON, you can define JPaths, which can filter things based on key names, for example. So you will only search through certain key names, key value pairs, if you so choose. And this speeds up the search and also limit the false positives that you can identify in other key value pairs where you know there's no PII to be found. Or if, for example, you have some very specific use case where you only want to match on employee names, but not, customer names, for example. I'll go ahead and click OK. I'm gonna create another search matcher. This one is just gonna match on emails. Again, I'll browse for a data class, the pre-existing one we have for emails. And I'll create another rule. This one I'll just make a hashing rule just to demonstrate, different types of rules that we have. And all of these rules as they're created are then saved in our rules library. So you can go ahead and browse and, select those same rules so that you can apply them in the future without having to redefine them. The last page here is just PDF configuration. This is just for PDF specific issues that can be encountered. So for example, if the ciphertext is longer than the original text, we might want to be able to do different things to it. We might also want to search through embedded images within PDFs, which we also support in Word documents as well. I'll go ahead and click Finish. That generates this folder here with this particular config file. You can see we have a form here which we can edit in the future if you want to modify any of the search parameters that we've defined previously. And what I'll do is I'll go ahead and click Run As and search and remediate to perform this search and masking on those two particular sources. Might take about 20 seconds. Initial startup is usually the slowest, but when you rerun the jobs, it tends to get faster. So the job is finished a while back, so I'll just go ahead with the rest of the demo. The first file I'll open up is just this text file containing, the list of matches. So you can see things like Jane Johnson, John Doe, Carl. You can also do emails here. So carl123@gmail.com. So you can see the pre-trained model is fairly good at identifying names already. So we've seen some things like Bruce Wayne up top, which I'm guessing came from Batman, from the movie lines over here. But there are cases where you might not be satisfied with the particular matches that you've had with a name identity recognition, in which case you would want to be able to retrain a model to recognize names in that particular context more effectively. Before I go into that, I'll just show the dark data model, which gives you a different sort of representation of the same information where search results are placed under different documents. You can also do things like go ahead and open this graph here, which shows you. I'll open up in my browser. It shows you the different file formats that you have found, which ones you've managed to mask, and which ones are currently unprotected because there were some failures in masking all of it, for example. Not exactly certain why there is one unprotected. I'll have to check that out. But going back here, yeah, so in essence, oh, there we go. We might want to actually see the search results. So I'll go back to the DarkShield demo remediated bucket and reload it. And here we can see the different files here. So I'll open up, say, the Word document just to demonstrate that here we have Jane Johnson, which was format preserved and encrypted to as indicative. In essence, again, these names will be nonsensical. If you want to replace names with real names, you might want to use something like pseudonymization. Format preserved encryption is good because you don't have to maintain the pseudonymized list somewhere, which can be, fairly unsafe. Instead, all you have to do is maintain the passphrase that was used to perform this encryption. This JSON file as well, you can see that our emails were hashed. The subject line had Carl Jr., who was former representative encrypted in both cases. This unstructured or free flowing text also had the name encrypted in both cases. Named entity recognition recognizes names based on the context that they appear in, it doesn't save a list of names that it just says, oh, well, that's a name because it's in our list of names. So it'll be able to work for British names as well. Again, it depends on the context that they appear in and the domain that you're using it in. Chinese names might be harder. The named entity recognition models recognize names not based on some preset list of names, but based on where that name appears in the context of a sentence. Here I'm just going to show off that a PDF document was also, encrypted. So you can see that the account number was scrambled. It was the 90052. I forgot the exact one. In all cases, it was encrypted consistently to this. And then Jane customer, that was both of those cases were in the set file that I added previously. So Jane customer was replaced with this encrypted name. Now, the reason why I use the set file in this context is because forms are, not sentence specific. They don't lend themselves well to named entity recognition because it's not in a sentence format. So here, small town was recognized as a named entity, as a person, even though it wasn't, just because that's the sentence it thinks it appeared in. So you can see some of the pitfalls of named entity recognition in terms of just form data, for example.